So let's see if this sounds familiar to you. You're trying to get work done in your shop, but you're struggling, you're stumbling over stuff. There's like things that just need to get fixed, but you just got to get the job done. There's projects you want to work on, but they're like too monumental to tackle all at once. Now in this video, we're strategizing. We're shutting down the shop, we're forming up teams, and we're working on big projects to make way for a new product line coming through the shop. We're calling it Lean Day 2025. Let's get started. All right, we got Alex here. We're surprising everyone. Alex, today's Lean Day. What are you working on right now, and what are you fixing that bugs you?
I'm fixing that this tank hasn't been cleaned in about 2 years.
Wow.
So, and it definitely shows in here. So.
Yeah, okay, so how are you cleaning it?
Right now I'm just scraping off the sludge. I vacuumed out the coolant first with that guy right there.
Yep.
And
Okay.
just gotta get this tidied up.
Yeah, love it, thanks. You working on other stuff later today?
Yeah, I'm gonna organize our tool setter.
Yes.
Just get everything underneath cleaned up and throw away anything that we don't need.
Yeah, great. So you got to understand, we got to shut down the machines. This is a perfect time to shut down all the machines at the same time and do the same type of maintenance instead of like, oh, we got to shut down this machine, got to shut air, whatever, power. No, shut everything down, do multiple things at the same time. Let's keep moving. Paul.
Yes.
It's Lean Day 2025. What are you working on?
I am clearing this chute that the conveyor sits inside of.
Okay.
Over time, chips just end up gathering around the sides and in the back. So when I pulled this thing out, it was just all caked. So I spent some time getting all that out of there. And now I'm doing a spot cleaning just to make sure it goes back and it's nice and ready for the next year.
Awesome. So these UMCs are notorious for not having great chip evacuation. So yeah, this is a big deal to shut down the machine, pull out the conveyor, scrape the sides. There's ways and covers that we want to remove. We want to do some deep cleaning, multi-hour process. So awesome. You got more stuff you're working on later today?
Doing some air stuff, making sure that leaks are all tidied away, and then all those little areas, I'm sort of obsessed with all these little areas that are outside of our immediate view, underneath carts, underneath the shelves, getting all those tidied up and cleaned up.
Deep cleaning.
Deep cleaning.
Love it. All right. Speaking of air, I did this thing where I'll show you our air system. We'll go there next. But I turned off the air to the shop, and then we have residual air in our pipes. If you do the math, we have 35 gallons of compressed air storage in just our blue piping. It's called rapid air. When we turned off the valve, there were so many micro leaks in the shop that you would go from full pressure to, you would lose 80% of that compressed air within 10 minutes. So 10 minutes, 35 gallons, 3.5 gallons per minute of air loss alone. That's a waste. Let's go talk to John because he was kind of heading up that thing. Let's go see what he did. Johnny 5, Lean Day 2025, what are you working on?
I am working on plumbing a light pressure of air to the live tooling.
The crazy thing is, this is an enclosed housing with no ventilation, just like ambient ventilation. So we're gonna put low volume of positive pressure with a bleed needle valve, I think, flow control valve, so we can just introduce some positive pressure to get that hot air out, because we were having overheating issues when we were doing long runs on live tooling. So there's a few regulators here. One of them is low pressure 1 bar. We found out that when live tooling runs, it has a little bleed air, and which is great because we're gonna take that bleed air and we're gonna plumb it into, explain it.
The live tooling panel here.
Yeah.
We'll take off this little panel that slides back, and we'll drill a hole in it and put a little fitting in there and run some line up, and we'll be good to go.
And then you got this open. What else are you doing when you have a machine open like this?
I'm cleaning all the joints. I'm cleaning everything. Any chips that I see that are stuck in certain areas, we'll clean that out.
This is crazy. Like, you would never see those chips unless you took off.
This whole area here is covered, so you never go in here.
Yeah.
So if you look in here, there's some chips stuffed in the back there.
Oh man.
That you can't see.
Yeah. Multiple panels had to come off.
Yeah, exactly.
Yeah. Okay. Cool. I'll be back because what else are you working on today?
I'm working on fixing airlines, little fittings everywhere that are leaking.
Yep.
And hopefully we'll have, by the end of the day, we'll have 0 air leaks.
And how did you find those?
So obviously you're going to listen for them at the end of the day, turn off the air, air compressor and all the machines enlisted. But I thought, you know what, let me just go around with some simple grain and put a rag behind it and shoot it and see if it leaks.
Easy,
And
simple.
most of the time, it's just a couple of wrench turns and you're good to go.
Crazy, crazy. All right, we're gonna save a lot of energy. Compressed air is the most expensive utility in the shop, so this is a big deal. Like little hiss, no big deal, another day, it's a big deal.
Yep.
Thanks, Sean, I'll be back. Mondo, surprise. Lean Day 2025, what are you working on?
Oh, I'm doing the compound card.
Yep.
Before it looks like this.
Yeah.
Now we're doing it like this.
Yeah, so this was like the old school. We just printed them out. You just write on it. We have a digital Kanban system, and anyone can make them, but it takes a skilled person to pull like the right photo. So you're going on the internet.
Yes.
You're finding them. You're attaching them to our
Yes.
Google Sheets. Yeah.
Yeah.
What was the problem with these? Because we're fixing things that bug us. What's
Yes.
wrong with this
well,
one?
sometimes this one you barely can see it.
Yeah.
Sometimes you barely can see the letters or
Yeah.
the numbers. So with this one now, there's no problem anymore.
Exactly. And if
Fix
this
it.
gets smudged, lost, we can
Yes.
reprint it because these are
Yes.
serialized.
Yes.
Yeah, awesome. And then we also made like new 3D printed drawers, which use the, what's the system called? The Gridfinity system. And so those go in and then different heights, different widths, and then it just holds tools more densely in our cabinet. Great. What else are you working on?
Today I just changed the relay on that.
Yeah. Okay. Oh, good. That's
yeah,
easy.
that's
All right.
all it is.
Yeah. All right. Thank you. Oh, real quick. This is what I'm working on. So we have our dual air compressors. This is a 20 horsepower, a 10 horsepower. So the deal here is you want redundancy and you also want like load balancing. So during the day, we have the majority of the machines running. That's gonna be on the 20 horsepower because it's feeding two 240 gallon tanks. So they're hungry, the shop's hungry. At night when we have about up to, let's see, we could go lights out with soon 5 machines, the 10 horsepower is fine. So give this a rest during the night. This one goes during the night. This is the night owl. It also gives us an opportunity to service one while not shutting down the shop. Like for example, we're keeping the shop going while we're changing the oil and filters on this second one. What I'm gonna do is, well, these go into a wet tank, which is at this point, a small tank. It's an 80-gallon tank. Then it goes to the air dryer. Then it goes to the dual 240-gallon tanks. You want the dryer between your wet and your dry tanks because when there's a surge of usage, you don't want rapid amounts of air going through the dryer. The dryer is only a 59 CFM dryer, so you want a nice even airflow between them. Now the big tanks are pressurized to up to 140 PSI. We have a shop-wide regulator that brings it down to 115. So even during a surge, like these are not going to empty. So it creates a nice consistent airflow between the tanks. But when we moved in, which was like what, 3-4 years ago, something like that, we just, I'm gonna throw us under the bus and say we haphazardly just put everything together to get up to speed, get it up and running. We've just run with that and we're like, someday, at some point, we will fix that. Well, today's the day. We're gonna mount the dryer on this custom made plate on our 80-gallon compressor, so it's all one cohesive unit, because now we've been going around, we've been winding through this maze, turning off valves, things like that. It's all gonna be one front panel here where it's like control panel, control panel, control panel for the dryer, and then the valving right here. So this is my area that I'm gonna work on, design the plate, the guys machined it. One approach we did for Lean Day is we had tasks that need to be completed for Lean Day, and then our Lean Day task. Like you don't want to say, okay, let's redo the piping, and then realize you need like, 4 fittings and 3 valves and 2 hoses. Like you don't want to do that. So you pre-think it, you put that in our system that we use to manage it. It's called Trello. Maybe I'll show that later. But basically just like apply brain power, which misused brain power is one of the 8 wastes. Apply brain power, prepare, and then you have like the all hands on deck like today, and even you can hear right now, we still have just a handful of machines running. So it's not a total shutdown, it's a partial where we prioritize the big picture team-based improvements. All right, now let's go to assembly. Okay, our new guy, he's been with us for several months. He's never been on camera. Tanner, we're gonna go surprise him. Tanner.
Oh.
Lean Day 2025. What are you fixing that bugs you today?
I am fixing a rack that we're putting in a bathroom.
Nice.
And I am getting rid of some parts that we don't need anymore.
Love it. So we're
just getting more table space around here.
And you're keeping things shipping. That's awesome.
Trying to,
yeah. So we had supplies scattered all over the shop, put them in one place so we're not over processing, we're not wasting motion, we're not walking around. It's just, there's a supply cabinet, right?
Yes, sir.
And you're building that. Great. So we're improving the way that we assemble stuff for efficiency. Awesome.
Yes, sir.
I'll be back.
Sounds good.
All right. Hey, while we're here, let me show you some things. So I know we've shown this in other videos, but really fine tuning. Okay, if this is gonna be a build station for our Pro, Mini, and Max 4 pallet systems, own it. Like we're like, oh, let's just, it's kind of crowded, let's build Minis over there, or let's do like Max 4s over here. No, it's just like, get the stuff, build the fixtures, prove out the process. And when I say build the fixtures, we'll build them digitally first. We will 3D print them. I'll show you something, prototype fixture. And then we'll go to a more durable material like a UHMW, anything that we're gonna machine. So 3D print them, prove the concept. Once it's proved and improved, then we spend the time to machine it for durability. So let me show you that fixture. All right, for any of our vacuum customers, you'll recognize our vacuum power unit. This was a engraving test, we'll call it, whatever. Okay, so one of the things that we have to do, one of the last things we do is we have to bolt on what we call the mount plate on the bottom, and then this mounts the table. So it's kind of finicky when you get it here. You're trying to hold this part and then screw it together, and then there's a fitting that goes on the side, a muffler, which is these guys right now. It'd be much easier if when we go to assemble these, if we had something that did the holding for us. So this drops in, the mount plate drops in, and then you can just put this on the table, use the fasteners. You can actually tip it on its side and access these screws, tip it on the other side, put the muffler in there, and then you could just literally turn it over on the table and then it's ready for boxing. So again, this was 3D printed. This one, yeah, we love mistakes around here. I did a calculation that was wrong. I flipped the dimension. See these notches here? They're supposed to line up there. This is why you don't machine right off the bat. This is actually the third 3D print, and still there were things like, hey, you give it to the guys and they start to work with it, and they're like, oh, it'd be nice if it were like this, or at one point when they tipped it on the side, this was tipping out, so there's little like edges here, so it doesn't necessarily flip out, it just stays put, that type of thing. So the fourth print, I think, just finished, and we'll give that a test. Oh, another thing is, you could put this in either way. So I put in this slot so that it interferes with the knob, and you'll never get it seated because it interferes. It only goes one way. So that type of thing. That's called pokey-okey, which is called mistake proofing. So yeah, fun stuff around here. Continual improvement, making things easy around here. All right, let's keep going. All right, so we're back at the Doosan 220 LSYC. We have this project. John, talk me through what you've done so far.
So we were able to plumb into the actuator that pumps the air into the turret.
Yeah.
And we teed off of that, and we are coming in, and we're gonna run a line into the panel. There's a removable panel on the bottom of the housing, and I bolted a fitting in there.
Yeah.
Drilled a hole, bolted a fitting in there for the airline, and we'll run it out and we'll loop it so that when the Z axis goes back and forth, it'll just move.
Kind of drapes. Yeah.
Just drapes.
Yeah. Okay. Come on over here, Nathan. Here, it's a 1 bar, which is 14.5, 15 psi. So it's just a little bit of it's just a little bit of pressure that apparently goes into the turret to create like a positive pressure in the turret, so that any coolant, oil, that type of thing that goes in doesn't get into the turret. And it's only active when the live tools are running, which is perfect. So come over here, Nate. What we did is, this is the line, and this is all metric, so it's 6 millimeter. We teed off, we went to 6 millimeter line, then that goes to this. We'll run this into that cabinet, which will also create positive air pressure. The best thing about it is it's clean air, it's dry air, and because it comes through a chiller, it's cool air. So it's exactly the perfect air for going into that. We'll show you some shots in a second. All right, let's hook it up though. We've got all this excess. We want the excess because we'll need to go to the maximum Z travel, and then we'll determine where to, we'll drill a hole in it, put a grommet in, do all that good stuff. So, you like it?
Yep, love it.
Yep.
I'll turn it on and we'll see. You won't really see it work.
You won't see it. Yeah, that's the thing. You won't see it. You'll just know the effect. So we have before data, like running at a certain RPM for time, and then we have a thermal gun to see how hot things get. We're gonna see what it looks like after this.
Correct.
Yeah. All right, we're gonna keep moving. All right, I'm not gonna bug Juan. He doesn't like camera. He literally just ran off. But we have mist away mist collectors. Grinders are open machines, so how do you get mist out of the area? How do you collect it? Well, it's not like an enclosure where there's one point of like extraction. So we kind of created this point of extraction. We had a few different variations. Here, let's step closer. Mist away come into different, there's like plenums and things you can buy, different things off the shelf. But what we did is we had flex because the column moves up and down. We plumbed it directly to the opening above the wheel because there's an option for overhead dressers, but it collected too much, not even mist. The wheel was spinning off coolant, and so this thing was getting like coolant logged immediately. So a little ingenuity, we have a saying around here, if it's worth doing, it's worth doing poorly. So that's basically like, just make progress, and then from there, improve on that progress. Don't aim for perfection. Perfection is the enemy of progress. So we just found like a from a restaurant supply store, just a basic plastic bin for bussing tables. Flipped it upside down. We had some leftover brackets that we just mounted. So now we're not collecting coolant from the spinning wheel, we're collecting it adjacent outside of the housing. It works beautifully. Now every now and then, if you notice up here, it'll collect, and then when the mist collector is turned off, then it drips down. We just have a tube that we have a clear kind of like sight glass tube. When that gets filled up, you just undo it and it drains back into the system. Little improvements like that fix what bugs us. Still moving. Okay, we're back in assembly. One of the things that we wanted to do, remember, we wanted to create dedicated workstations. Another catchphrase that we use around here is no half measures. So we don't want to Swiss Army knife everything. We want a dedicated, like, great tool. Okay, we don't want to have tools that are like where we're duct taping things onto things to make them work. You know, like, we don't do that. So anyways, around here, we changed this over for our new product. Check it out on our website. It is our Vice pallet, working name, but it gives all the components that go into it. We're working on build stations right now so that we can basically have ways to manipulate the part, kind of like a build board that you can manipulate. Like a build board is something where it's literally a board. We want things that can help articulate it so we can access different sides of the product. So yeah, what we've done here looks really good. Let's actually go take a look at the Vice pallet. It's in action right now. Okay, so this is really the product that motivated us to have a lean day where we shut down so we could bring things up to speed, reconfigure cells, clean stuff, make improvements, because to introduce a new product with a lot of components into an existing value stream can kind of get chaotic unless you add that intentionality of saying, no, this is going to be almost like our new flagship product. I have tremendous confidence in this product. And we need to tool up, whether it's machine or configurations within machines, we need to tool up to make this efficiency so we pass on the savings to customers. Okay, so this is what we're calling our Vice pallet, only because it's a Vice built into a pallet. Now in this configuration, it's on our Pro pallet system base, but we configured it so you could go direct clamp with our included toe clamps. If you have a 96mm mounting pattern, you can bolt in, or ideally you already have our Pro pallet system and it just goes right on. So quick changes, it's auto, indicated, all that good stuff. So I actually showed this in summer of 2023. Now back in that video, it was a 6-inch version. One of the things we want to always be doing here is questioning the why. And when I think of like a vise, I think 6 inches. I think they're just ubiquitous in the industry. But I thought, man, we've got a pro pallet system that it's ideally connected to. Let's go 8 inches. Let's go industry standard jaws. Let's go dual station. No, wait, let's go quad station, because quad station, that's the way to go. Let me zoom in and then I'll show you some of the close-ups of what we did to finally bring this to market. Let's take a closer look. So the first thing I'm going to show is that these jaws auto adjust for different parts, different part sizes. So it's a dual station, so it auto adjusts. Dissimilar metals, you can put it in one station. When it makes contact, then you can load up the next station. Load up the next station, tighten it. Wow, that's awesome. Then it's done. When you go to undo it, you'll notice that one jaw will move first. Once you do that, you pull it, keep turning it, the back one stops, and then the front one automatically goes. If we wanted to mix and match part sizes, we would again put one in, and then say we wanted to stand this up here. That clamps down, auto adjusts. So then once that backs out, keep going, and then you can tell they both kind of move in unison. For larger part sizes, depending on the geometry, you can just pull this vise back, and you want to keep your workpieces close to you, so we recommend this close jaw. If you wanted to go even larger, you can remove this center jaw, drop bolts in here, and lock it down into these pin positions, and then you get full travel, and you can hold parts up to 16 inches. But for now, we'll just show you similar material parts. Now we call it the vise pallet, meaning it can go directly mounted with the flick of a wrist and an air valve onto our pro pallet system. You can also use toe clamps on these edges here, in the back edge, and a T-slot table. Or if you have a 96mm system, you can go in from the bottom and adapt it to any type of system you have on your table already. This is a chip ejection port. So one of the classic problems of dual station vices, or vices of any type, is chips getting packed between the jaw carriers. And this chips will get pushed out. Also, if coolant is blowing down here, it has a place to go. It goes out these two ejection ports. We also designed it to use industry standard jaws. So if you have 4-inch jaws, typical industry standard stuff, it will work. Soft jaws, or you can use the serrated hardened jaws that come with it. Okay, I just finished the first part of my task, which was we took a plate of material. So this was actually one of our customizable top plates for our SmartVac vacuum system. It got damaged in transit. We sent a replacement to the customer, of course, came back, and we're like, well, let's repurpose that. Really easy operation. We drilled 4 holes and aligned it with the holes in the plate on this tank. There used to be a piston style pump here. We sold that off, salvaged the 80-gallon tank, and then put 4 more holes. The bottom of this air dryer actually has tapped holes that are ready to go. So what I need to do at this point is lift this onto it, but not just lift it on, turn it around. It's a bit cumbersome. It's also pretty heavy. I would say this is probably 60, 80 pounds, maybe 100 pounds, hard to tell. Obviously it's more than I want to safely lift. I'm gonna find, you know what, let's do this. I'm gonna go around and I'm gonna ask everyone who they think the 2 strongest guys in the shop are. Let's go do that. Hey Juan, question. Who do you think are the 2 strongest guys in the shop?
Strongest?
Maton.
Well, maybe Alex and John?
Alex and John? Okay.
Yes.
All right, thank you. Hey Tanner.
Yo.
Who are the 2 strongest guys in the shop?
Strongest guys?
Also, you can vote for yourself.
Say probably Alex or John.
Alex or John? Wow, okay. Let's keep moving. Ooh, perfect. Who do you think are the 2 strongest guys in the shop? Physically strongest.
Alex for sure.
Alex for sure, okay.
And I think Armando.
Armando.
Like
Sleeper.
muscle to
Yeah.
it's a compact powerhouse.
Power to weight ratio. All right, I like that. All right, let's keep going. All right, we got our leader over here. Hey, John.
Hey, Jay.
Who do you think are the 2 strongest guys in the shop?
Oh my gosh. Everyone is.
Okay, physically strong.
Oh.
That's the wrong. That's the right answer and the wrong answer.
Strongest?
Yeah.
Alex.
You can vote for yourself too.
Alex and Tanner.
Alex and Tanner going the youth vote. I like that.
Yeah.
All right, let's keep going. Armando. Sorry, scared him. Question we're asking everyone. Who do you think are the 2 strongest guys in the shop? Physically strong.
I'll say Juan and Tanner.
Juan and Tanner. Good answers. All right, let's keep going. We're going to get them on break. Alex, who are the 2 strongest people in the shop? You can vote for yourself too.
Physically or mentally?
Ooh, good. Physically.
Maybe me and John.
You and John. All right, let's keep going. Does big equal strength? Oh, okay. All right. Who are we missing? Oh, here, give me that. Nathan, who are the 2 physically strongest in the
I'm gonna
shop?
go Tanner and Alex for sure.
Tanner and Alex. All right. Man, no one said me. I don't know. All right. I think we have one more person. Let me go find him.
I'm gonna go with Juan and Alex.
Wow. Okay, that's great. Thank you. Got him. John, congrats.
Thank you.
You came in 2nd place in strongest guy in the shop. Yes, that means you're going to help me with a project.
Okay.
Who do you think came in first?
Alex.
Yeah, Alex is a clear runaway winner.
He's
Who
a
do you
big guy.
Who do you think came in 3rd?
Tanner. Juan.
Juan. No. Juan got a lot of votes. Let's head over. All right. So we're just gonna lift this, turn it around so it faces that way, and we'll put it here. We'll get it as close to these holes here. Beautiful. Man, nice. Scale of 1 to 10, how hard was that?
Maybe a 5.
Johnny, scale of 1 to 10, how hard was that?
I would say 3 or 4.
3 or 4. Dang.
It's really stronger.
Beast mode. All right, Paul. Yes. How did it go? Because we are, looks like you've mopped the floor, you're good. How was this whole thing?
It actually turned out to be a little easier than I thought.
Okay, cool. Yeah.
Yeah. So just, mark the bolts to make sure that we were locating again properly so we didn't have any weird angles that
Yep.
were off on the inside. Supported it with the engine lift,
Yes.
slid it out. It didn't fit, so we moved it back, opened the door,
Oh.
put the head of this in that machine.
So smart.
And then we were able to get it out.
Okay, so we like our tight spaces because wasted motion is
Right.
one of the 8 wastes of lean. So I love the ingenuity. We think smart around here. We think eliminating waste into it, clean it. Would you give any tips to UMC owners?
Yeah, make sure you have enough space to get that out. Otherwise, you're just going to be living with chips.
Yeah,
Because if you can't get it all the way out, there's no way to flush that chute
Yeah.
entirely.
crazy.
So give yourself enough space, and clean this more often than once a year. I think.
Yeah.
I'd say maybe like every 3 months. Being that it is really not that big a deal
Yes.
to pull it out, slide it out. It's just making it so much easier when you're not having to deal with packed chips. Packed chips in the chute toward the back because it's basically a cast iron
Yeah.
with lips like this.
Yep, yep.
That this chute fits inside of.
Right.
And there was just chips.
Crazy. They weren't like collected at the bottom. They were everywhere.
They were everywhere inside of there.
Crazy. We got bad coolant return, and so now it's so much better.
Yeah.
Awesome.
The other thing, another tip is there's lots of connectors,
Okay.
especially if you have 2-3 spindle coolant.
Yeah.
Lots of connectors that need to get tracked and reconnected in the right order.
Maybe label them.
Yeah. So I labeled everything A, B, C, D, E, F, G, whatever.
Yeah.
Was very orderly about removing stuff.
Yep.
So when I went back in, I also had a little video. Just, I mean, sounds like a no-brainer idea, but really, like, just track your connections so that you're not having to go, because you'll forget fast.
Well, I think the no-brainer is not using your brain and not labeling. So it's easy, it seems obvious, but don't forget it, right?
Yeah.
All right, thanks. We're gonna keep walking around. Thanks, Paul. All right, so this is not a lean day tip, but it was a previous lean day, but we installed kind of this like snaking conveyor here. Let's take a look. So company like ours, we're doing dozens and dozens of boxes per day. The old workflow was to put them on carts, stack a cart. When it got tall, like 6-7 feet tall, you roll it out, you grab another cart. We thought, why are we lifting? Why do we have an excess inventory of carts? Why are we over processing? Why are we putting ourselves in a position of lifting? That's crazy. So we just had beyond our shipping tables, you push them onto a conveyor and it rolls out here. So here's UPS showing up like for the first time. And then like if this guy were parked over there, we could pull this conveyor closer to the back of the door. And I think we do that on the high volume days. Today's a mid volume day. Isn't that cool? So this articulates to go right to the back of the door. The UPS guys around here love us, so I think they do. I'm gonna say they do. So I mean, pretty cool. All right, let's keep going. Okay, so we got our 2 compressors. The lights on, 20 horsepower, goes in the wet tank, plate, great. I was hoping, which is a terrible business strategy, I was hoping that I measured correctly and the threaded holes in the bottom lined up. Close enough. They had to wrench them into place, but this is fine. The guys said, oh, it's pretty high for the controls. True, but we have this plugged into a smart switch that turns on and off automatically. Okay, so this was our tooling crib area. It still is our tooling crib area. There's maybe if you watch our second channel, Pierson Plus, I talked about this. I talked about like movables and monuments. A monument is something that doesn't move and should not move. We're talking machines, ancillary equipment, that type of thing, physical structures. Those things you have to just work around, and so it's important to get that layout correct. But in the case of a shop crib, like if there's carts or desks, or we even put our tool presetter on wheels, our digital height gauge and granite plate. The only thing with some of those higher end tools is just make sure it's level, so we have levels on them. We wanted to create an area where we could clean it, where we could service it, where we could repurpose it, where we could reconfigure it. And the other thing, I didn't even realize when we moved this in, the riggers, if you want to go back and watch the installation video, the riggers rolled in this huge 95-gallon tank thinking, oh, we can get to it. And Alex is like, actually, we can't get it out. It's a good thing that we have things on wheels. So wheels allows you to wheel your stuff into position in a non-permanent way so that you can expand your shop floor, your gemba, your workspace. So normally if it were a monument and not a movable, a monument, you would say, well, we have to allocate walk space in between them. With a movable, you can take away that walk space that's not often used. So that's why we put as much stuff as possible on wheels. So I encourage you to stop and do your own type of lean day, make those improvements. The payback is incredibly shorter and a lot less costly than is often thought to be. So until next time, go innovate your production.